All right, page 707, number 9. What is the momentum of a photon of violet light that has a wavelength of 4 times 10 to the negative 400 nanometers? So what is the momentum? So we know P is equal to h over lambda. So 6.626 to the negative 34 joule seconds over, what was it, 400 times 10 to the negative 9 meters. Calculator, oops. So 6.626 to the negative 34 divided by 400 to the negative 7. And you should get a momentum of 1.6565 times 10 to the negative 27 kilogram meters per second. Okay. Number 10. What is the momentum of photon of red light? Wavelength of 700. So exactly the same thing, just the bottom number gets changed. 626 times 10 to the negative 34 joule seconds divided by 700 times 10 to the negative 9. So 6.626 to the negative 34 divided by 700 to the negative 9. And that should be 9.4657 times 10 to the negative 28 kilogram meters per second. Number 11. What is the wavelength associated with an electron moving at 3 times 10 to the 6? So this is de Broglie's wavelength, h over mv. So 6.626 times 10 to the negative 34 joule seconds divided by 9.109 to the negative 31 kilograms times 3 times 10 to the 6th meters per second. 6.626 to the negative 34 divided by 9.109 to the negative 31, 3 to the 6th, and you should get 2.4247 times 10 to the negative 10 meters. Turn the page. What is the velocity? What velocity would an electron need to have if it has a wavelength of 3 times 10 to the negative 10? So again, de Broglie's wavelength, only this time h over mv. You're rearranging for velocity. V equals h over m lambda. 6.626 to the negative 34 joule seconds divided by 9.109 to the negative 31 kilograms. And it's telling us the lambda, I think it was 3 to the negative 10. Was it? Yes. All right. So 6.626 to the negative 34 divided by 9.109 to the negative 31 times 3 to the negative 10. And that should give you a speed of 2.4247 times 10 to the 6 meters per second. All they did was switch this speed number with this, and you got the same answer. I could have done that in my head if I had noticed. Number 13, electron is accelerated across a potential difference of 5,000. So V is equal to 5 times 10 to the 3rd volts. What is the velocity of the electron? So remember, potential is equal to EK over Q. So 1/2 mv squared over Q. So solving for V, multiply by 2, divide by m to get the speed. So 2 times 1.602 to the negative 19 coulombs times by 5 times 10 to the 3rd volts and divided by 9.109 to the negative 31, not 19 kilograms. And you will get, oops, this is v squared. And then don't forget to take the square root. So 2 times 1.602 to the negative 19 times 5,000 divided by 9.109 to the negative 31, and then take the square root. And you should get a speed of 4.1937385 times 10 to the 7th meters per second. That's part A. And part B wants to know what wavelength is associated with this. So lambda equals h over mv. So 6.626 to the negative 34 joule seconds divided by 9.109 times 10 to the negative 31 kilograms times the speed you just found, 4.1937 to the 7th meters per second. Lambda equals 109 to the negative 31, 6.626 to the 34, and you should get 1.73454 times 10 to the negative 11 meters. Done. Okay, so that was it for your homework.